Good evening to my power electronic lecturer. My name is Mitresh and my metric number is 23DM21F1015. Today I am going to explain about step-down chopper with in DC converter. So, this, so what is chopper? Chopper is a static device. It converts fixed DC input to a variable DC output voltage directly. It is also known as DC to DC converter. It is widely used for motor control, also in use in regenerative braking. It's an electronic switch that is used to interrupt one signal under the control of another. Advantages of disadvantages of chopper. Advantage of chopper is it is high performance, regeneration, adaptability in execution, lightweight, compact size, rapid response, low cost and dynamic reaction time. The disadvantage of chopper is efficiency drops dramatically for high-power applications due to large switching losses at high operating frequencies. The supply voltage is doubled for freewheeling diode. The double the supply voltage is the peak load voltage. There is two type of choppers, which is step-down chopper and step-up chopper. So what I'm going to explain today is about step-down chopper. So the function of step-down chopper is a step-down chopper is a static device that step down its DC input voltage. The value of the average output DC voltage of this chopper is less than of its fixed DC input source voltage. Principle of step-down chopper. So here's the circuit diagram for chopper. A step-down chopper with resistive load. The thyristor in the circuit acts as a switch. When thyristor is on, the supply voltage appears across the load. When thyristor is off, the voltage across the load will be zero. Here's the waveform for the step-down chopper. Here's another circuit diagram, which is step-down chopper with RL load. When chopper is on, supply is connected across load. The current flows from supply to load. When the chopper is off, the load current continues to flow in the same direction, though due to energy stored in inductor. The load current can be continuous or discontinuous depending on the values of L and duty cycle T. For a continuous current operation, load current varies between two limits, which is maximum and minimum. When current becomes equal to I maximum, the chopper is turned off and it is turned on when the current reduces to I minimum. So this is the waveform for the circuit. Okay. Another topic for the COC2, single phase to single phase cycloconverter. Single phase cycloconverter. A single phase to single phase cycloconverter is a type of cycloconverter whose input and output are single phase AC. The basic function remains the same, which is frequency changing. A single phase to single phase cycloconverter may either be midpoint type of bridge or type step up or step down cycloconverter. Working principle and function. A single phase to single phase cycloconverter is a power electronic device that converts the input single phase AC voltage into a variable output AC voltage with the same frequency. The basic working principle of single phase to single phase cycloconverter involves a series of control switches such as thyristors and that are triggered at specific angles of the input waveform. The cycloconverter can operate in two modes, namely in the step-down mode and the step-up mode. The phase cycloconverter. So here's the circuit diagram. It consists total of 8 number of thyristors P1 to P4 in example 4 for positive group and the remaining 4 N1 to N4 for negative group. Here, positive group doesn't mean that the SES will conduct for positive half cycle of input AC supply, rather it means that when P1 and P2 or P3 and P4 conducts, the output voltage is positive. This circuit diagram, during the positive half of the input supply voltage, A is positive with respect x. This makes the resistors pairs and P1 and P2 and N1 and N2 forward bias from WT equals to 0 to WT equals to pi. So here's the waveform for single phase to single phase cycloconverter. Show you explanation. So when forward bias thyristors P1 and P2 are turned on and WT equals to 0, the load voltage is positive with terminal A positive with respect to terminal 0. At WT1, the conducting thyristors P1 and P2 are post-commutated and forward bias thyristors where N1 and N2 are turned on. As soon as N1 and N2 are turned on, the load voltage becomes negative with terminal A, negative with respect to terminal O. At WT2, the thyristors pair N1 and N2 are commutated and forward bias thyristors P1 and P2 are fired to turn it on. The load voltage is now positive and follows the positive envelope of input supply. After WT equals to pi, thyristor pairs P1 and P2 and N1 and N2 becomes reverse bias, but the thyristor pairs P3 and P4 and N3 and N4 are forward bias. These forward bias thyristors can be turned on and force commutated from WT equals to pi to WT equals to 2 pi. In this way, high frequency turning on and force combinations of pairs P1 and P2, N1 and N2, and P3 and P4, and N3 and N4 gives a high frequency output voltage at the load terminal. Here's the advantage and disadvantage. Frequency control. Cycloconverters can change the frequency of an AC voltage without the need for a transformer. This means that cycloconverters can be used to control the speed of AC motors by varying the frequency of the applied voltage. Reduce cost and size. Cycloconverters are typically smaller and less expensive than the equivalent transformer based on frequency converters. High efficiency. The conversion efficiency of a cycloconverter is typically higher than of a transformer-based frequency converter. Smooth output waveform. The output waveform of a cycloconverter is typically smooth and distortion-free, which can be important in applications such as AC motor and control. Low harmonic distortion. The use of cycloconverter can reduce the amount of harmonic distortion in the AC voltage waveform, which can be important in applications such as power factor correction and reducing electromagnetic interference. Disadvantages. Limit power rating. Single phase to single phase cycloconverters are typically limit relatively low power rating, which makes them unsuitable for high power applications. High harmonic distortion. The output waveform of a cycloconverter contains a significant amount of harmonic distortion, which can cause problems in some applications. For example, harmonic distortion can cause the interference with other electronic equipment, can result in reduced efficiency in electric motors. High voltage stress. Cycloconverters typically operate at a high voltage, which can lead to issues with insulation and electrical breakdown. And lastly is the power factor. Cycloconverters typically have a poor power factor, which can increase power consumption and reduce efficiency.